JJ here, and then might be here. This is PGC, no? PGC. So I will call that PGC. Okay. If I'm going to sum up forces X, so klaro kayo nga, PGG equals to PGH, no? So whatever the value of PGH will be also the value of PGG. So if this is compression, this is also compression, no? So strictly, if I'm going to use the equation above, this will be PGG minus PGH is equal to 0. Is equal to 0. That's the equation. And this one is PGG. And there we got PGG is equal to minus 62.5 divided by 3 kilonewton. Okay. Now, however, if we sum up forces Y, take note that these four forces have vertical component. So, if I'm going to do that, I will have minus P GC, then I have minus P GH kind of theta, no? So I will just multiply this by 0.6, and this one is 0.6 also, 0.6. And then there's also another one, 0.6 is actually 3/5 of PJG. So all of them are negative because they are directed downward. But we know that PGC and PGG, PGH and PGG is negative sign. So and then we have also minus 10 is equal to 0. So if I'm going to transpose I can divide all by 0.6. So I will have PGC 0.6 of PGC is equal to we have positive 0.6 plus 0.6 is 1.2. 1.262.5 divided by 3. Okay. Because they have the same sign, they have the same value. So I just add them, combine. So 0.6 and 0.6 will become 1.2. And then their sign will become positive because negative, there's the negative value here. Like that. And then I have minus 10. Okay. So that means I can have BC. So equal to you have 1.2 times 62.5 divided by 3, that's 25, minus 10, that's 20, no, 25 minus 10, you have 15, divided by 0.6, you have 25. This one is transposed to the other side, become positive. This one is added. 0.6. Yes, that's it. That 1.2 na siya. Positive. So 62.5 divided by 3 times 1.2 minus 10 divided by 0.6, you have 25. Let's see, this is 25. Wala man. So, this is a 25 really. Minus 6. So, the PGC has no 0.6. Okay, it's only a minus. Only the 2 has angle here. So this one is not here. So PGC here is equal to positive 15 pm. Okay, so I solved that already. 15 pm. So that's the PGC. Okay, so I have solved the 2 points already. So that means I have determined this, determined that, determined that, determined that, determined this. So that means there is will be just by doing the same process, no? But it's so tedious, so I will stop at this point so I can proceed with another topic. So you can do that actually. You can finish all of this by doing joint to joint. No? So the next joint is you go here, you go here. So here you have already determined the three of this. No, the three of this. Okay. So that's it. No. So you can also go here, no? Because here you have two points. So going up there, so bali patabo nimo, no? But you can also coming from A to A. No? So the next joint is C. So if you have joint C, this is it, no? With this one known already. This one is known already. This one is known already. Okay, that's known. Okay. Para dapat kopya na siya pa-paste. Okay. So I have already remaining three joints, no? Two joints. See, I will add one more. I will add one more. So you see. So let us see that this one is known already. No? This one is known as. I will move this to here. Cut. Then I'll move it here. Paste. Move it here. Okay. So this one is 15. And this one is that is this is the value CH PCH is negative 25 over 3, negative 25 divided by 3, and this one here is positive 70.5 times 4, that's 70 over 3, 70 divided by 3, 70 divided by 3. Okay, so this is 70 divided by 3. Okay. This one is 70 divided by 3, plus this one is, we consider it as PCD. Okay, well, this one is CJ. Yes, CJ. Okay. So you notice that they have only two unknowns here. Two unknowns. Okay. So the sum up versus Y first. The sum up versus Y first. Copy. Yeah. This one is to be erased. Okay, if we sum up versus Y first, we can solve actually. So Y because there are only three forces here that has Y component. First is the positive 15. Yeah, that one. And then you have also the arrow is going up. The horizontal component is time sign of theta, or the vertical component as sine of theta, 0.6. And then you have the value of negative 25 divided by 3 kilonewton. And then the other one is also has inclined up, so that's still positive 0.6 or positive sine theta times P C J is equal to 0. Okay, 0. So we can solve actually, this is supposedly black. Okay, so with that, I can solve PCG. PCG equal to, okay, so I have 15 minus 0.6 times 25 divided by 3. We have 10. So transpose to the other side, it will become negative 10. So PCG is negative. Okay, negative na siya. Divided by 0.6. Okay. 10 divided by 6 kilonewton. So that is 10 divided by 6 here, PCG. So we have 10 minus 55 divided by 0.6 times 25 divided by 3. It's 5. 5. Minus minus 10. So, dapat ini siya, negative na siya. Negative. So, you have 0.6 times 10 divided by 6. 25 divided by 3 times 6. 0.6 times 25 divided by 3. 10. 10. So 10 divided by 0.6. This is 16. No? This is 16.67. This is 16.67. 16.67 kilonewton. Okay. The 16.67 is 50 divided by 3. Yes. 50 divided by 3. Okay. So 50 divided by 3, 50 times 1 times 0.6 divided by 3 is 10. Okay, so that's it. So here, if we sum up forces x equals to 0, we have P, CD, we have plus, we use 0.8 rather than 4.5, PCG, PCG, then we have minus 70 divided by 3, then we have minus again 0.8 times negative 25 divided by 3 equal to 0. Okay, so we can solve PCD. PCD equal to, so all the negative is transposed to the other side, it will become positive. You have 70 divided by 3 will become positive. But the negative 0.8 times negative 25.3 will be positive. When it converted to the other side, it will become negative. So we have minus 0.8 times 25 divided by 3. We have 16. And then we have minus, we have CG we have here. So that's minus will become positive to the other side. So we have plus 28 times 50 divided by 3. So we have 30, positive 30 kilonewton. Okay, so we have solved already this one, and this one. So we have only this one. Okay, so if we use this, we can see that if we are going to submission forces x equals to 0, okay, mission forces x equals to 0, and if we are going to submission forces x equals to 0, this member is DE, this is PDE, P, this is PCD, okay, pasang kanina. Okay, so aktualisasi juga. Nasa course dia. Gunta ni siya o P DE. Ya, kini sa itaas. Gunta ni siya o P DG. No, DG. DG as in disc jockey. No? DJ. Then sa ubos, this is 20 PL. Okay, when you do submission forces X, we have PDE minus PCD is equal to 0. But we know already PCD as negative, positive 30, so PDE is also equal to 30 kilonewton. Next is with the submission of forces Y. That's a lot simpler because if the figure is simple, you can actually do, no? So we have PDG, you have minus 20 is equal to 0. So you have PDG is equal to 20 kilonewton. So you have only one joint here. So here, this is already 20. This one is CG minus 50 divided by 3. And this one here is, what's it here? Okay. So if you use this, you have so many member, no? But we have already drawn the free-body diagram. So anyway, what we need is just this GE, no? This PGE. This one, no? This PGE. That's PGE. PGE. Okay. And this is 20. Maybe we can do this by summing up forces horizontal, and this one is CG. We have CG here minus 50 over 3. Minus 50 divided by 3. But this one is GG. GG. So instead of 62.5 over 3, this is negative 62.5 divided by 3. Now, summing up forces X equals to 0. Okay, we have 20 times PGE. We have minus 28 times 62.5 divided by 3 minus cosine of theta times 50 divided by 3. 20 has no horizontal component, so that's equated to 0. So if I'm going to convert to transpose to the other side, it will become positive. 0.8 will cancel. So we have P E equal to, that will become positive, but you have negative, so still negative. P is negative, and that is 62.5 plus 50. 62.5 plus 50, you have 112.5, of course, is divided by 3 kilonewton. So that's the answer. 112.5 divided by 3, and that's equal to 37. So we have been able to solve all of it now as we go here. So that's how method of joints is being solved. Okay, I will. Okay. So the one for our lesson is to solve this using method of section. So method of sections. Sections. Okay, method of section. Now, if you are going to do method of section, in method of section, actually class, ang ano na this dili tanan members solved. Like for example, I want only to know solve solve for P PG PGG PCG and PCD. PCD only. There are only three, no? So if you do not know method of section, actually, what you will do is you use method of joint, and then before you reach PGG, PGJ, PCJ, and PCD, you have to solve all of this from joint A, B, C, H, G, so that you will arrive into here, no? So that means that if you do method of joint, you can also only solve PGG if you solve already some of the members here, which makes you takes longer to reach there. Okay. So to go direct is you will use method of sections. Okay, so this is the topic that we are going to discuss this uh, afternoon, method of section. So, method of section is utilizing section only. You are going to cut, no? To cut the member you are interested, so that it will be changed with an arrow with a known, no? Of the member with which you are going to solve. Like for example, I am interested in PGG. Now, fortunately, if I'm going to cut this, no, if I have a samurai or I have a katana, I will slice from GG up to CD, no? Slice it there, no? So just like this. If I have a katana, I will slice it from here. Okay, slice. So what happened is that there will be the structure will be divided into two, no? So the left and the right, okay? So what, because three members are being cut, so they will be replaced by an arrow that goes away from their node. Okay. So what happened if I'm going to cut that? This is the section. So I will have a structure like this. Copy. Isa sa kuliang number yung mga load. So what happened if I'm going to slice it? You have this. Okay, this is what happened. Copy. If I am going to slice this one, no, to slice that, so I will have either this structure, ako di balhin. So using method of sections, I'm going to slice that. Now, why I am interested in cutting this DG? Remember that I am going to interested in finding the DG, CG, and CD. So I need to cut this, no? Cut this all. Now the idea is to separate this structure wherein you can present this with an arrow. No? This one, I will just copy that one. Copy. And then paste it here. Okay. So I will still have here the 27.5 and then paste again. I will have this load. This one is so that there will not be one. I put it here and then paste again. This one is for this course. Okay. Okay, so that there will not be suggested and move it there. And the other one is this one. Okay. Okay. This is the other one, no? The other one also contain the same, no? Yung isa, no? What happened to the other structure? Well, the other structure will be like this. Muning may tapos isa ka structure, no? So, okay, that one, no? Ako lang siya i-move. Di pala. Hindi ka to. That's it, no? I will just remove this. Home. Cut. And this one, okay. Home, copy, paste. So, still have to be there. But, going away, this node, okay, copy that. Paste again. This one is going away from node J. And paste. This one also is going away. Node J, this node. Okay. Now, you have a reaction here. See that? Okay. Now, this is 27.5 PN, while the other one is 22.5. 22.5 PN. Now, this one, really, okay. So, ang may tabudan ako na lang siya butangan o text box. Text box. So, hindi siya, muna siya gitawag o P GG. Okay, but should have no line. There should be no line. Okay, that's PJJ. Then I copy that one and then paste. Uh, okay, copy this one. Copy, paste. This one could be PCG, PCG, and then copy, and then home, paste. I could have PCD here. Now, the same also here. This is PCG. Okay, okay, that's PCG. Okay, that's PCG there. And then this one, copy, paste. So this one is PCG over there. Then here, home, copy, paste. This is PCD. This one is PCD. Okay. Okay. So by slicing this, no, to the members you are interested to solve, is you create two structure. You created two structure. No, all the forces are intact. The 27.5 is still there. The 10 is still there. You have the 20 and the 22.5 are there on the following structure. And members that being cut, because they are being cut, they are replaced by arrow, no, like that. Kung kamot pa na naputol, i-bandage, pero it's very gross to imagine that one. So let us just imagine something that if you cut a member, there should be will be replaced by an arrow that's going away. They are assumed to be tension. And their name is the name of the member. For example, this one, this is J to J, C to J, and C to D. So they are inside the parenthesis there. No? So now the idea here is that if the whole structure is in equilibrium, so it follows also that this is are called substructures, no? This is the left substructure, this is the right substructure, resulting from slicing it into two. Okay, each of the substructure are also in equilibrium, no? So if that is the case, we can use principle of equilibrium, no? So now the question is which substructure I am going to use. It depends, no? You can use the left or the right, which even is convenient for you. So the term convenient will be the factor of choosing which structure you are going to consider. You consider only one because either of the two will produce the same result. Okay, so it's a matter of convenient, and convenient is sometimes a choice, no? A choice. Okay. So maybe we can replace the term convenient as economical, meaning not very laborious, or it is easier. No, that's what we mean by convenient. Okay. So if I am going to consider, like for example, the number of anons I am going to consider, if I am going to use this particular section, if I'm going to consider this structure, I have three forces which are 10. So I have three. The fourth is the reaction, 27.5 plus 3. So I have 7 forces to take care. Okay. Whereas if I'm going to consider the other, I have 1, 2, 3, 4, 5 only. So when we say convenience, you know already which one to choose. I am going to choose the last one. No? But there's really nothing will stop you if you are going to choose this. No? Okay. So if I am interested in solving the PGG or one, I am going to be interested in PCD, I will sum up moment. No? So if you are going to use method of section, in method of joints, we are using forces X and summation of forces Y. In method of section, you will use, no? use summation of forces X, summation of forces Y, as well as summation of moment at any point. No? This one is equated to 0, so that it will be equilibrium. This one is equated to 0 again, and yes, but other we use the Greek symbol. That is what they call sigma. Sigma. Okay? Sigma represents summation. Okay? Ilan lang ang kundaan, no? Summation. Okay. I am not only limited to summation of forces X or summation of forces Y. We can also use summation of moment. But summation of moment is useless when you are going to do summation of joint, no? Because joint are what we call collinear, no? Collinear, what they call concurrent forces, no? Concurrent forces, meaning they converge into one point only. Okay. So here, if you trace all the forces, they did not converge into one point only. So they have what we call moment arm. So moment center, so that your unknown will be reduced. Okay. Just like for example, if I am going to sum up moment at E, okay, at least one force is passing through A, the PGJ, leading on okay, and also PCD. So that means that there is one unknown PCG, okay, whichever we can solve, no? So if I'm going to do that, summation of moment, if I'm going to do that, no, I like that point. Y summation of moment at E, but I am going to make this as subscript. Subscript na siya. Okay, is equal to 0. I like this. Why? If this will be my moment center, at least two forces like this GG and CD converge at point A. They do not have moment center. So their moments are 0. While CG do not pass to point A, so it has moment. Okay? And also 20. You can only have two forces actually. So if I'm going to use positive CCW, meaning positive, rotates in a positive manner. Why? Because it is counterclockwise. If you hold your hand there and determine, if you put your index finger at 20 and imagine where 20 is rotating about your index finger, it rotates in a counterclockwise manner. So therefore, that's positive because that's our sign convention. The moment arm of 4. So meaning that is 20 kilonewton meter because 20 is as unit of kilonewton and 4 as a meter. And then if I am going to break further the CG here, of course, if you know this distance, if you know this distance, fine, that's okay if you know that distance. But you can also break that into a component, no? Okay, because this is the line of action of CGA. It's very long actually, no? It can extend somewhere there, can extend somewhere there. So you know that, no? As, but no matter how long it is, it does not pass through A. It has a moment arm. So you need to determine this. Okay? So one way to do that is to have it broken somewhere here, no? Broken somewhere there, no? I will make what do you call this one? I am going to change the color of that into blue. So I can make that into what we call component. Okay. So this component is the cosine of theta of CG, that's 12. And then at the same time, I have also the vertical component. Okay. This is what we call the sine of theta PCG. And this one is cosine of theta PCG. So this one here, is 20 because cosine of theta is 4/5. Okay, so we have another here, while this one is sine of theta. No, it says 0.6 of PCG. PCG siya. PCG. PCG. If you are going to take the square of this and the square of this and add them together and take the square of it, will become PCG because 0.6 and 0.8 are unit vectors along x and y direction. Okay, so you can break this anywhere, no? But again, the point of breaking them into components is a matter of choice, no? If I'm going to break here, of course, I know this distance. This is 6 meters. Okay, so meaning if I'm going to break it here, I have this one rotating about a positively. So I have positive 0.8 PCJ. How about its moment arm? The moment arm is this one. Okay, this one. So it will become 6 meters is equal to 0. Okay, so PCJ from that equation, you can solve it as PCG is equal to la minus 20 times 4 divided by 6 divided by 0.8 period. So that's negative 40 divided by 20. 50 PCG equals to 50 at 20. Wala na bilain, 20 times 4. The 0.6 8, so times 6. This one is times 6. No. PCG is 20 over 4 divided by 6. 20 times 4 divided by 6 divided by 0.8. Negative 50 divided by 3 kilonewton. Okay, what we got here? PCG. That's correct. 50 over 3. Okay. Now, question is, what happen if I am going to break them here? Here, I am going to break them here. So, this one will be here, and this one will be that force. What will happen? Well, this 0.8 of PCG passes through A, so that means that it cannot make movement. Only the vertical component. So, what happens is that if I'm going to do that, my equation will change as 20 times 4 times 0.6 times 0.6. But the moment arm, instead of 6, this distance is 8. No? Buha ka 4. So, this one will be 8. Okay? So, this one will be 8. And this one will be 0.6. The same thing will happen. So, either, no? So, I'm going back to the original. Focus lang bumalik. Bumalik sa na to. Okay. So, that's it. No? That's it. Okay. How about if I am interested in CD? CD. Okay? If I am interested in CD, I think I am going to sum up moment at J. No? Why? At J, at least the two unknowns, the CG and GJ, are converging at G. If you make that as your moment center, you instantly eliminated these forces because they don't create moment at J. Their moment arm are zero. However, CD is 3 meters away from J. So the next I'm going to do to solve for CG, I'm going to sum up moment at J like that. But I will make this a lot bigger. Okay, maybe 16. Okay, so that is the equation. So if I'm going to make this as moment center, I have only two equations that rotates. The 20 is useless. No, it cannot make moment at J. At least three forces are converging at J. The 20 kilonewton, the PCJ, and the PGG. How about the two, the CD and the 22.5? Their line of action, no matter how you extend them, will not pass through J. Thus, it creates moment. So the equation will become PCD. If you put your index finger and join J, it will rotate in a clockwise manner. Thus, this one will become negative. I put negative. Okay, negative. Okay, using counterclockwise positive. Okay, so this one will be erased. PCD times PCD times 3. 3 na iyang distance. Meaning, from point G to D is 3 meters. Okay. And you have 20, 2.5 rotates about J in a counterclockwise manner with a distance of 4. So, mo ni ang imong equation. Doon na siya plus plus 22.5 times 4. And that is equals to, well, we compute that, 22.5 times 4 divided by 3. Positive 30. Positive 30. Okay? That's CD. Let's see what is CD in our previous calculation. CD, CD, CD. 30 here. Here, 30. 30. So, the same answer you will get, no? Same answer you will get, 30. So, I solved na the two of this, no? I solved na the two of this. Okay? I solved already the two unknown of this, which is CG and CG. No? Now it's time for GG. Okay? GG. To solve for GG, you just use summation of forces X. Okay, summation of forces X is equal to 0. Oy, basa na. Bigyan na sa symbol. Ayan. Okay. If X equals to 0, but since that is forces, we just say positive to the right, no? Naman. Okay. Now, if we go back to the figure, JJ is directed going to the left, so the horizontal component of that, which is 0.8 times P JJ, okay, that's minus. Okay. And you have also minus PCG. You have also minus the cosine of PCG, CG. And then we have also another minus the CD. And CD we have already found it to be CD. And then I think there's none. There are only three forces. This one, this one, this one. The 20 is vertical, also the reaction. So, and then CD, we know already CD to be 30. No? So that means that we have 0.8 C P PGG is equal to minus times PCG, which is negative. So you have here 0.8 times 50 divided by 3. And then you have minus 30. So you have PKG, or baliktad. Pwede ka pong mabali-bali, no? No problem with that. PGG is 50 divided by 3 times with 8. Then you have minus 30. Divided by 0.8. You have 20.833. No? 20 negative GG. Negative 20. Negative 20.833. So what is that? 62.5. 62.5 divided by 3. Okay. So you have negative 62.5 divided by 3. Okay. So that's it, no? Okay. Kilonewton. So I got the same result as one. So meaning you can go direct now, and the structure you are going to choose will depend on which structure is convenient for you. As long as all the unknowns will be labeled, okay, and then you can apply equilibrium. You can even extend summation of moment into section. Okay, so that's how you solve it using method of sections. Now, for your practice, you solve. Okay, so as your on your own, solve the PBC, so that you have only one cut, no? PCH, CH, and PGH, using the methods of sections. Okay, so you have to continue that. No? So in doing that, because you are interested in this member, this member, this member, so you are going to imagine you are holding Wakasashi, okay, and then slice it here. No? So that will result into two substructures. You have the left and the right. Okay. Now, why you are interested in cutting GH, CH, and BC, not AE and EH, because if you're cutting IE and EH, the unknown will be EH and EB. You are not solving what is required. So you go direct to the one, to the problem. No? So recap, the method of joints is still okay, but it's not. It's a long shot, no? Especially if the member you are analyzing is in the middle. Why? Because if you are using method of joints, you cannot go directly there, no? So that is why you have to learn another method, which is method of sections. So the second problem that I solved this afternoon is done by using method of sections. That if you can follow our notes, so it's easy. No? Okay. So I will stop at this point, class, because it's already time. We have to go to another class with this.
Sir, pwede na pangutan na, sir? Kadali,
Yeah,
sir?
okay. So ito na nimo.
Regarding sa assignment 1, sir, kanang na-late ko og submit, sir, pero sa email na lang nako gi-submit. Okay na, sir?
Okay naman, kasi name.
Medrano, sir.
Kasi name.
Medrano. Medrano.
Okay. Sige. It's okay.
Thank you, sir.
So, ano lang. Okay. So, katong atong discussion karon, ako lang to siyang i-upload gyapon para nasa tay discussion notes, no. So, nga na. No, so, that's it, no, for this afternoon lecture session. We have already analyzed us using two methods, method of joints and method of section. So, they're easy actually, not thinking. Because if you think nga lisod na siya, mas grabe pa ka complicated ang real scenario, no. So katong atas simple gid kay itong atas mo itong anang atas sa mga payan bitaw, payan sa iro mga anak yo. If you want to see actual structures containing classes, you will really you will really that term amaze ba ka or something, but since you are civil engineering, so the term amaze is okay, no? So because why? When you will be professional someday, you will be paid when you are analyzing, when you are designing, and it depends if the structure is small, you have also a small professional fee. But if the structure is big, well, it will also commensurate, no? So that is our livelihood, no? By constructing, to construct a small structure, well, maybe it depends, no? But if you have a big structure and small structure, so it's assumed that the big structure is a bigger commensuration, no? Our of payment. Why? Because it requires longer to do it. Yeah. Okay, so kinsa pa yung na-late? So, wala na tingog. Pwede na ako mo sign off. Thank you.
Thank you, sir. Thank you, sir.
Thank you, sir.